In this video, I'm going to solve Exemplar class 9th mathematics chapter polynomial. That is chapter number 2. We'll do all question here. So let's begin with the first question. The first exercise here, that is 2.1. This is exercise 2.1. Now, if I see the first question, in the first question, it says to write the correct answer in each of the following, and where the first part of this question says that which of the following is a polynomial. Now, you should know that a polynomial always have a variable. The variable has always as a power as whole number. So let's see this algebraic expression. The first one is not a polynomial. Why? Because when I write this in the standard form, if I write this in the standard form, that is, this is x squared over 2 minus 2. If I transpose it to the numerator, this is x raised to the power minus 2. Now you can see here that this variable has power as not a whole number, it is an integer. So therefore, this is not a polynomial. Now coming to the next part, the second part, if I write this in the standard form, this is actually, if written in the standard form, this is 2 raised to the power half minus 1. We can write this as 2 raised to the power half and x raised to the power half. Clearly, you can see that here also the variable has a power as a fraction. And as I said, for an algebraic expression to be called as a polynomial, the variable must have a power as whole number. Now, say if I do the D part also, D part, you can see this cannot be written in the standard form, and therefore it's not a polynomial. Coming to the next, that is the last part. But you can see here that this is x squared plus 3 raised to the power 3 into x raised to the power 3 by 2. That divided by root x is x raised to the power half, right? Root x is same as x raised to the power half. Now, this is x squared. If I write this in the applying laws of exponent over here, right? If we apply the laws of exponent over here, we know that when same bases are divided, powers are subtracted. So x raised to the power 3 by 2 minus 1 by 2. So we get this as x raised to the power 2 into, this is 3 by 2 minus 1 by 2 is 2 by 2 and 2 by 2 is 1. So we got this as x squared plus 3x. As you can see here that both the powers here x squared as well as x raised to the power 1 are whole number. Therefore, we'll say that this is a polynomial. Now we are on question number 2. Now in question number 2, it says root 2 is a polynomial of degree what? That means you can see that root 2 is what? I can write root 2 as root 2 into 1. And you know that I can replace 1 as x raised to the power 0. As you know, any number raised to the power 0 is 1. So this is actually a constant polynomial, and a constant polynomial has degree as 0, right? So since the power of x is 0 here, therefore we say that degree of a constant polynomial is 0. Therefore, we can say that the correct option here is B. Now we are on question number 3. Now in question number 3, we have to find the degree of this polynomial. So when you look into it, possibly one of you may say that the degree is the highest power. So the highest power is 5 over here. You can see that the highest power is 5. Therefore, we can say that 5 is the degree of this polynomial, but this is incorrect. We can see that this is 0, this is 0, right? 0 multiplied any number is 0, and this 0 multiplied by any number is 0. So when written in the standard form, this is actually 4x raised to the power 4 plus 5x plus 7. So clearly now degree is the highest power and the highest power is 4. So we should say 4 as the degree of this polynomial. Coming to the next part, that is in the fourth part, here the question is the degree of a 0 polynomial. 0 polynomial is what? 0 is a 0 polynomial, right? So the degree of the polynomial is equal to the highest power of the variables. And we know that degree of a zero polynomial does not have any highest power. Therefore, we say that the degree of zero polynomial is not defined, right? So zero of a zero polynomial is any number. Zero of a zero polynomial is any number, but degree of a zero polynomial is not defined. In question number 5, it says px, which is a polynomial given here, and we have to find out the value of p2 root 2. So we know that we can obtain p2 root 2 by replacing x with 2. So it's going to be, if I replace this x with 2 root 2, this is 2 root 2 square minus 2 root 2. And this x again will be replaced with 2 root 2 and plus 1. Now we know that 2 square is 4 and root 2 square is 2. So it's 4 into 2 minus 2 into 2 is 4 and root 2 into root 2 is 2 plus 1. So this is 8 minus 8 plus 1. So clearly this get cancelled. So we get 1 as the correct answer for this. In the next part, we are on question number 6. And in question number 6, it says the value of the polynomial at x is equal to -1. That means, say, if I consider this polynomial, say px, right? The given polynomial as px, which is 5x minus 4x squared plus 3. Now, we have to get p minus 1. So what does it mean? That we'll be replacing x with -1. So clearly it is 5 into -1 minus 4 times. If I replace this x squared with x with -1, so it's -1 squared plus 3. Now this is 5 into -1 is -5. This is -4. -1 square is what? -1 into -1, that is 1 plus 3. Now this is -5. -4 into 1 is -4 plus 3. So this is -9 plus 3, which is equal to 6. So D is the correct answer for this. Now we are on question number 7. So in question number 7, we are given a polynomial px, and we have px is equal to x plus 3. Now the question is, we have to get px and p minus x. Now if I ask you what is p minus x, so p minus x, that means we are going to replace only x with minus x, right? So the sign of x will get minus x, right? The plus 3, as you know, that the constant does not undergo any changes, right? For example, if I ask you what is p2 or say p minus 10, you are going to replace this x with minus 10 and plus 3 will be as it is. So similarly, here we are given px, right? We are given here the px as this, and we have to get px plus p minus x. So px is this, and p minus x is minus x plus 3. Now we have to get the sum of these two. So if I say, for example, if I add it, so this is px plus p minus x on the left hand side. On the right hand side, it is x plus 3 and plus the other one, that is this one, minus x plus 3. Now, if I open this bracket, it's going to be plus minus is minus and plus 3. So x and minus x get cancelled. So we get 6 as the correct answer in this case. Now, this is question number 8. In question number 8, right, what we have to get is, let's say if I make this correctly visible, we are on question number 8. It says 0 of a zero polynomial. Yeah, I told you that degree of a zero polynomial is not defined, but 0 of a zero polynomial can be any real number. So the 0 of a, as I said, degree of a, let's begin once again. We have to get the 0 of a polynomial, 0 of a zero polynomial. So 0 of a zero polynomial can be any number, but when we talk about the degree of a zero polynomial, then it is not defined. Now, coming to the next question, that is question number 9. We are on question number 9, And over here, we have to find the zero of this polynomial. So finding the zero of a polynomial is same as equating this polynomial with zero. That means we can write 2x plus 5 is equal to 0. Now you can isolate x. First I'm transposing 5 to the other side and then 2 on the other side. So this is minus 5 over 2. So that is the correct answer for question number 9. This is question number 10 now. In question number 10, we have to find one of the zeros of this polynomial. So there is two ways. Either you can replace one by one x with this, and you figure out in which case you are getting this as 0. And the other, which should be shorter here, is finding the zero of this polynomial. So I can take this polynomial as px and equating this with 0. If I equate this with 0, you know that this is a quadratic polynomial, and quadratic polynomial can have up to 2 0, and we find the zeros of quadratic polynomial by method of factorization. So I'm going to factorize here. 2 into 4 is 8, and from the factors of 8, we are doing middle term factorization. We have to obtain 7. So it can be written as 8 into 1, because 8 minus 1 is 7. So this is 2x squared, splitting this 7x as 8x minus x minus 4. The common between first two term is 2x. Dividing this by 2x, we are getting x, and dividing this by 2x, we are getting positive 4. Now common from the last two term is minus 1. So dividing this by minus 1, it is x, and this by 4. So we have x plus 4 and 2x minus 1 are the two factors here. Now, in order to get the 0, we will equate this with 0 and so with this. Now, in the first case, for example, if I equate this one, if I equate x plus 4 with 0, we are going to get x as minus 4. And equating this with 0, that means 2x minus 1 with 0, we are going to get x as half. Now, check here. We just had to get one of the 0 here. And although we have two zeros, that is minus 4 and half, but as for the question, we have to get 1 0. So we'll say that B is the correct option. In question number 11, the question says that, so question says that if x raised to the power 51 plus 51 is divided by x plus 1, the remainder is, so we have to get the remainder. So what you should must be knowing from your previous concepts, that say fx is a polynomial, and if it is say divided by x plus a, then the remainder is obtained as f of 0 of this, which is minus a. So we are going to apply the same concept here. Now here the divisor is x plus 1. It is divided by x plus 1. So the remainder here, the remainder in this case is going to be, if I consider this to be fx, then it's going to be 0 of this, that is f minus 1. Once again, the steps involved here is, first you equate the divisor with 0 and obtain x, which is minus 1 in this case, and plug in the value of x over here, and that is the remainder. So that means the remainder in this case is, if I replace this x here with minus 1, what I'm going to get? Minus 1 raised to the power positive 51 plus 51. Now we know that minus 1 raised to the power an odd power. Repeating, this is an odd power. So minus 1 raised to the power an odd power is minus 1. This is minus 1 plus 51, and that is equal to 50. So the correct answer over here is 50. Now we have reached to question number 21. In this question 21, it says if x plus 1 is a factor of, we are given x plus 1, right? We are given x plus 1 is a factor of this, then the value of k is what we have to get. Now, since First, I'm going to get the 0 of this. So 0 of this, that means equating this with 0, that is the divisor here, we get x is equal to -1. Now, using factor theorem, if I replace this x with -1, then I should get 0. So we know that x plus 1 is a factor of the given polynomial. It means that replacing x with the 0 of the divisor, we should get 0. That means 2 into -1. I'm replacing this x with the 0, that is -1, plus k times -1 should be equal to 0. So -1 square is 1. So 2 into 1, and this is k, right? K times -1 is minus k is equal to 0. So 2 minus k equal to 0. Make sure you first transpose k to the other side. Otherwise, there is a chance of error. Basically, the error is that mostly you transpose 2 on the other side and ignore the k. You say that this is 2. So that's why I say that, suggesting you that transpose minus k to the right-hand side. This way, you will get a positive value of positive k, and therefore k is equal to 2. So the option C is correct in this case. Now, in question number 12, if x plus 1 is a factor of this given polynomial, then we have to get the value of k here. That we have already done. Right? We have to do the next part. 12th we have done. Now we have to do the 13th one. So in question number 13. In question number 13, we have to check x plus 1 is a factor of which of these polynomial. So the first thing that we have to do is to equate x plus 1 with 0. That means we can say that x is equal to -1. So -1 is the 0 of the divisor. Now in every polynomial, we are going to replace x with -1. The case in which we get 0 as the answer should be called the 0 of the polynomial. Now in the first part, I'm doing the first part, it is x cube, that means -1 cube plus -1 square. This is minus x, so this is minus of -1 plus 1. So I did nothing. I replaced x everywhere in this with -1. Now what I'm getting, -1 cube is -1, -1 square is +1, and minus into -1, that is +1, right? And this is +1. So with this get cancelled, we are getting 2. So clearly this is not equal to 0, right? 2 is not equal to 0. So this is not the answer. Now for the second part, let's say if I do this one, here also I'm replacing x with -1 plus x square, that is -1 square, plus x, that is -1, and +1. -1 cube is -1, -1 square is +1, plus minus is -1 and +1. So what do you see here, that -1 plus 1 get cancelled, and so is this. So we get this as 0. Now, since this is an MCQ, we can declare our answer that we can say x plus 1 is a factor of this. Now we are on question number 14. In this question, it says one of the factor of this polynomial. So we need to factorize it. And the theorems or the property we'll be using is the identity here. Let me write down the question. This is 25x squared minus 1 plus 1 plus 5x whole square. So we are going to apply two identities. Number one, we are going to apply a square minus b square as a plus b into a minus b. And further, we are going to apply this a plus b whole square as a square plus 2ab plus b square. Let's first proceed and then we will decide. Now, the first thing is clear that we are going to apply a square minus b square over here. Now, in order to understand this better, I am writing 25x square as x square and 1 as 1 square. Then we have this. I can expand, or we may take common. So let's say I am writing this only. Why I'm not expanding it this? Because we are going to get the same factor from the factorization of this. So I can write this one, applying the identity a square minus b square as a plus b into a minus b. So it's going to be 5x minus 1 into or let's say first 5x plus 1 and then 5x minus 1. 1 plus 5 is same as 5 plus 1. So I may write this as 5x plus 1. Now, you may be wondering why I'm doing so, because I'll be taking 5x plus 1 as common, and that's why I interchange the order. Now we can see that we have a common here, and common is 5x plus 1. I have taken as common. So on taking 5x plus 1 as common, what do we get inside? We'll get 5x minus 1 plus, there was a square times of this, and we have taken 5x plus 1 common. So we'll be left with 1 5x plus 1 as common. After dividing this with 5x plus 1, we'll be left with 1 5x plus 1. So we see that minus 1 and plus 1 get cancelled. And if I rewrite this, we have this as 5x plus 1. And from here, this is 5x plus 5x, which is 10x. Now, ordinarily, we write monomial first. So this is 10x multiplied by 5x plus 1 is the factorized form of this. Now, check here. We were asked to find out the factor. Clearly, 5 plus 1 is not a factor. 5 minus 1 is also not. 5x minus 1 is not, right? There is no 5x minus 1 here. We have two factors. One is 10x, another is 5x plus 1. Yeah, 10x is correct. As you can see that 10x is a factor of this. Now we did some 14 question, and we are left with some many more to do. So we can continue in the next video.